Hello everyone, welcome to my YouTube channel. Let's understand and explore autoencoders. Let's first of all, before even we talk about autoencoders, let's try to understand few examples. Okay, I will give you few examples. Just try and observe that. Okay, what are there in those examples? So let's look into the example number one. Okay, so where what we have is like I will provide you two sequences, right? So let's say sequences of numbers. So I will write here 6, 7, 5, 4, 9, 9, 2, 8. Okay, so maybe this is a number, right? And if I give you another numbers which are like 2, 4, 6, 8, then we have like 2, 4, 6, 8, then we have 10. Okay, then we have 12 and so on. Okay, and 14, then we have 16. Okay, then we have 18, then we have 20. Okay, so these are the number sequences. Okay, so first one is this one and this one. And similarly, let's say if I give you one more like this, we have, let's say this. Okay, so in this one, like the first guess when you will see in normally, so what you will do is what our brain sees that. Okay, or maybe as a layman, which one will be easier to remember. Okay, so I'm guessing that you may tell that, okay, second and third, these two are easier to remember. Okay, but let's say if you don't know, like if you haven't observed that, okay, there is some sort of pattern or there is some sort of sequencing here which is happening. So here, if you see, it is nothing but x plus 2, whatever is an input, or not x plus 2, I will say at every index it is going to give you around 2 times x it is giving you, right? If I talk about this sequence of number, and if I talk about the next sequence of number 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, and so on for this one also. Here it's 2 times x, here it is 10 times of x. Okay, so only I have to just find out this pattern, right? I have to just find out this pattern, and if I am able to do it, then I will be able to remember a longer sequence as well, because I know that, okay, there is some sort of pattern is there, right? So in the same way, now if I talk about, or if I have to model, let's say if I have to model in a neural network, so what I have to do is like I will simply write this. If I talk about these sequences, so I can simply write in this way, like we can have a one neuron here. Okay, where you are having input as an x, okay, and it is giving you output as a 2 times of x. That's all. Okay, so that means the weight is equals to is going to be 2 of x. So y is equals to, here the model, if I want to model this one, so there will be a phi activation function, which is nothing but it's going to be linear activation function. Okay, and we have the input as w times x, and plus bias is going to be 0 here, because we just have to model this. And here this will be a linear function. Linear means y is equals to x, whatever you put in as an input, and it will give you an outcome. And so if I try to model this, okay, and this one, w is equivalent to 2, so it will appear as y is equals to 2 of x. Okay, so that's how I can model this. Okay, I have to remember this, only this functionality. Okay, that's all. I will be able to predict any number. That means I was able to find out this pattern. Now this is one example. Okay, so that means it is easier to remember longer sequences if there is some pattern involved, right? Now, same way, if I give you one more example here. So let's say if you are having, if you have to prepare, let's say 20 units or chapters in an exam. Okay, you have to prepare to score good number of good marks. Okay, but let's say before few days back or few days before your exam, okay, few days before your exam, I'm giving a general life scenario. Your teacher said that out of 20, the first 15 chapters out of 20 are important. So how this sounds? This sounds good, right? That means you have to just focus on 15 chapters instead of 20. Okay, so that means it will become easier for you to like first of all prepare. Apart from that, it will also be easier for you to score better, right? Because instead of 20, we are focusing on 15, right? This is one of the examples. Now let me give you one more example. So let's say if you are recording, right? Let's say if you are recording something, if I'm recording this lecture also, like take this example only. So, okay, so recording through your phone, okay, or what, let's just video recording. Okay, so video recording through your phone or camera. And so what you're doing in this case, you are recording a three-dimensional information and presenting it on a two-dimensional screen. That means the projection, like the 3D projection on a 2D wall or maybe on a 2D monitor. So that means what you're doing, you're providing a three-dimensional information where you need three dimensions. Okay, where like the in the world we are, this world is three-dimensional, right? There is a depth involved it, but in the TV that depth is missing, but still we are able to perceive everything, right? So in all these three examples, if you can understand one thing, that there is something about the information. Okay, that means we don't need the entire information. Okay, we need some information to perceive things or take decisions. Let me give you let's just think of one more example like this. uh, let's say if I talk about the English language. Okay, if I say that you have to prepare for an exam, okay, for an English exam, or maybe let's say if you are building a chatbot, right? If you are building chatbot, so before building a chatbot, what you have to understand? Okay, so what is the prerequisite here? That your model should understand the language, then only it will be able to converse. Okay, then it will be able to respond. Okay, it should be able to understand, some language understanding should be there. Okay, it should be able to understand the context, then only it will be able to answer it, okay, automatically. Then apart from this, if I talk about the kids, right, so we have to show them, let's say, a few times that, okay, let's say if I talk about the way they learn alphabets, right? So from there, like from the beginning, they'll try to, you have to just show it them for the few times, and then they will be able to recognize that object in any scenario. Okay, they will be able to classify it very easily. Okay, and if I talk about these lectures also, okay, present lecture that you are watching, so in this lecture also, you don't have to remember the entire thing. You just have to remember the gist of it. That's what it is important for you. Okay, and based on that, you can proceed further, or maybe you can go in depth of the above other subjects. Okay, or in the subjects of this, if I talk about this autoencoder topic, so this is just a beginning. Okay, so you have to just find out the gist of it, and then you will start applying the knowledge, or you will provide the solution to a company. So do you think that you have to remember the entire lecture? No, right? You have to just remember the few things of it, okay, few core concepts, because that is the only important parts. Rest of the things is like about, it's just the discussion part, right? And similarly, if I talk about present lectures summary, similarly, if I talk about a chapter of a book, okay, so you don't have to remember every line, right? Every line or every example, everything is not important there. Only few part is important. That means again summary. So in all of these examples, in all of these five examples, if you try to observe one thing, that we are trying to condense or reduce the amount of information which is needed to take any further decision. Or in short, if you have studied machine learning already, so you may have remembered the concept of dimensionality detection, where you have studied something called as principal component analysis. So, at this same way, autoencoder also helps you to condense, or you can say reduce the dimension of the information that is coming from the data. Okay, so they have to just reduce it. Okay, so that you can, your model can learn better. It will only focus on the things which are important. Okay, and based on that, it will be able to classify or do regression or whatever it is required. Okay, so that's where the autoencoders come into picture. Okay, so now let's look into the formal definition of autoencoders. If I talk about the formal definition, so it's nothing but, it's an unsupervised technique. It's an unsupervised technique in which artificial neural networks, they become capable of finding latent, or I will say hidden features or information in the raw input data. Okay, that means they're reducing the dimensionality. They're trying to find out the latent or hidden representation in the, and in that particular data, which is also called as, and this latent hidden information is also known as latent slash hidden info. This is also known as encodings. Okay, that's what is happens in autoencoders. Now how this is achieved, let's try and understand. That is very interesting here. So how this is achieved, that means, let's say if you're providing an input, right? So if you are providing an input to an autoencoder model, and you are reconstructing it, you are reconstructing the same information that you are providing. So that means your input and target both are same. Okay, so it's a self-supervised, you can say. That means it has to predict itself, or maybe it has to create itself. Okay, but so it looks easy, right? It looks a very trivial job here, very easy or simple job, but not. What we are doing here is, in this autoencoder, we have to put some constraints so that it can only focus on the important part. What are the constraints? Constraints in that means, you will limit the number of neurons in the hidden layers. How this is achieved, I will tell you. Okay, other constraints, that you can add the noise. can add noise into the input, so that what will happen, that model will be able to, even though because there is noise or even though there is some constraints, still it will be able to find out the exact pattern that we are looking for. Okay, or some like hidden patterns that we are looking for. Now how it is achieved, so let me give you an example. So let's say if you are having a data which is having three columns, okay, and you are going to feed this as an input, okay, and now what will happen, this input will be fed here into a network, okay, where what will happen that this will go into a, this is our buffer neurons, right? If you can remember from the classes of deep learning. So this is buffer neuron, it does nothing, it's just a representation here. And what it will do is, like, we will introduce only two neurons in the hidden layers, okay? And then after that we will try, if you are reconstructed this information, so obviously at the output layer you will need three neurons. So in this way, this middle layer is behaves as an encoding layer, okay, and this one is your output layer where you are getting the reconstructed. So what we did here, we are actually forcing this three-dimensional information to pass through a 2D, okay, 2D encoding layer. So this is a three-dimensional info passing to a two-dimensional network. So in this way, we are forcing it to like learn the weight in such a way that if we have to only use only two out of these three, so it should be able to do something here. Okay, it should be able to represent the same thing. So it will try to find it out that, okay, whether we are able to represent this 3D information into 2D or not. So that means what we are doing, we are reducing the dimension. So what kind of benefit we will get from here? So see, the benefit that we will get here is that we will take this first part of this, okay, once you have done the training, okay, so what will happen, it will try to predict that, okay, this is x1, this is x2, and this is x3. It will try to predict that. So in order to do that, it has to learn the weights here, okay, in order to do that, it has to learn the weights here in all these edges, okay. So in because of that, what will happen, so if you are forcing this one, and there will be, obviously there will be a loss, right, because you are not providing the sufficient information to produce the same output. So what you're doing is, like, obviously there will be some sort of loss, and because of the loss, what will happen, back propagation will happen. If the back propagation happens here, so obviously these weights will getting updated. So let's say the training is completed, okay, you have got sufficient, let's say you are able to reduce the loss, okay. So the result of that will be that you will get a network here, which is, if I just took at this part, okay, I will copy paste here. So you will get such a network here after training that will be capable of representing the same information x1, x2, x3 into only two dimensions. Okay, that is your, let's say, let's call this as x1 dash and x2 dash. And now what you have is, like, you have, instead of passing a three-dimensional information, you will just pass these two-dimensional information. And after that, whether you want to create any, let's say if you want to create a classification model or maybe anything, okay, let's say if you want to create a classification or binary classification model, so you can simply attach one more neuron here and you can just pass on to a y unit, and then you will see that, okay, if you try to train it now, it will work. It will actually give you a, maybe it will give you fast result, because by this time it is able to learn the like hidden or latent features of it, of the data. So in this way we can reduce the dimension. So that's how the autoencoder works, right? So I hope you have got the general idea here. Now we will use this as a demo in the next lecture, so that you will have a concrete or thorough understanding that what autoencoder is. So let's get started here. So right now I'm at my GitHub repository here. So this is my profile, and I will click on new here, and I will create a new repository. I will choose one template here. So I will just choose a basic template, even though if you are doing it for the first time, so it's not a problem. So you can include actually all, you can even use this repository, okay, this particular template for your project as well. Okay, so I will just choose one, like, let's say it's called it as autoencoder basic demo. Okay, description also I will write it that, and then I will make it as a public, okay, repository, and then I will click create repository. Okay, so this will create a basic repository which is just having some like clones. Okay, so specifically it will be having getting no files and all, okay, and notebook and some configuration files. So maybe we will not be using all of it, okay, so because we are going to use very basic important needs that we have. So let's click on dot here. If you just press dot here or full stop in the keyboard, so it will open a web editor here. And now what I will do is I will get rid of some of the things which are not even needed here. Okay, so let's get rid of so in src, okay, there is everything is there intact. Notebook, we are not going to use it, okay, and then empty. So these two folders are not going to use, even the configuration part if it is required, so we will try. Otherwise, in this particular demo, it is not required. So I will click on these three and I will delete all of them. Okay, not needed. So deleted them permanently, and then init.sh. So let's try see if it is having. So we need okay, so we need main.py file, and making of the directory will not needed because src is also present here, so not needed. Okay, so we can actually we need to create some init.py file, or maybe okay, utility files we can create, so that is needed. Okay, so we will keep it as it is, and I think there is nothing else is required. Okay, so yeah, I think that's all for this. Okay, and yeah, I think this is all. So we can now commit these changes. That is, let's call it as first commit because it's a just preparation we are doing right now. Okay, so now what we can do is go copy and just copy this. And apart from this, let's add the requirements as well. So we will need TensorFlow first of all. We will need Plotly because I'm going to show you that okay how to plot this, and 3D plot will be needed here so that I can show you that okay how this information is getting converted from 3D to 2D. Okay, and then we have I think we need NumPy as well. Okay, and we need pandas as well, and apart from that I think there is nothing else is required. This is more than enough. So we will save it and then we will commit the changes like updated requirements. That's all. Now we are ready to go to the github.com here and we will clone this repository. Okay, so let's copy this and I will clone it in the local. So I will open my terminal here, right click and open terminal, and here just paste git clone and the paste these. Okay, that's all. So it is now we are at we have prepared the basic things, basic setup is ready, and now we can make use of your local VS code here and we will make use of that. Okay, so yeah, so we are here and now let's try to run. First of all, go to the terminal and just create the new environment. For that, this we've already written a bash file. Okay, so you don't have to do anything. Only thing that you can experiment here with, you can change the version of the Python if you want. Right now I'm keeping it as 3.7 only. So let me tell you that okay, what it is doing. This file is actually bash file. Okay, for this you need git bash intact here. Okay, so for that what you need is like if you have already installed git, so you must be having git bash also. So you have to just configure into this like into this configure terminal settings. If you go here, so here you can just select the like which one you want. Okay, like right now it is having window executable, so for that, so you can just check and update it here. So apart from this, you can see here this which one you want to select as a default, so you can select it. And apart from that, for more settings obviously you will have to go to the configure more terminal, but right now we are having it get bash. Okay, so now what we have to do is like you can see it is just creating an environment of first of all Python 3.7 conda environment is creating, and it is creating an environment by this env folder name. Okay, so that's all. And then after that it is also installing the requirements, and then it is also going to create these files which are some basic needs that we have. Okay, so let's do this. So I will write here bash and then init setup. Okay, that's all. So it will start doing the setup. So let's wait for a moment, and it will depend upon your internet connection also that how much time it takes to finish this. So let's wait for it. Okay, so now the basic setup is over, so we can now activate our environment. So conda activate and then environment. Okay, so we have all the data that you need, and then we can see here. So if we have created this utils folders, and there is some things like git keep file is there, so we don't need it here, so we can keep it in utils. Okay, if it is required, so we will like keep it, otherwise it's not needed, so we can even get rid of it. Okay, so but most of the coding that we were going to do is in the main.py. Okay, so now let's start. Okay, so first of all let's import TensorFlow here. Okay, and you can see that there it will actually give you some kind of warning. Okay, so we can get rid of it. What we can do is first of all we have to select this environment that we are working on. So I think it will show you here maybe. Okay, let me just check. There should be a work. Okay, if it is not, so we can even refresh it, so hopefully we will get it. So it may take some time. From here you can select. Okay, so we have this, yeah, workspace. Okay, so 3.7.3 conda environment. So now we have, you can see that it's gone. Now we can import numpy as np, import pandas as pd. Then we can even import plotly express as px. So these are the basic imports that we need, and then we can write here if this main input. Okay, and then what we can do is we have to define few function. Like one function will be responsible for generating a data, generate data, and then one of them will be required here to create the model. Okay, or to get the model. Okay, so these are the things that we need, and now let's start from here. So what we will do is, first of all, we will call for the generate data. Okay, so we will get the x underscore train. Okay, and we will get it from the generate data. Okay, so what we have to do in generate data, so we need first of all few things, like we need to know that, okay, what are the data points, available data points that you need. So data max data points we can write here, data points is equals to, let's say we are going for a 60 data points. Okay, then we have to tell, okay, how many rows we need. Okay, rows, not rows, actually we need how many columns we need. So columns wise, that what will be the column of the data. So we are going to leave 3 because we are creating some sort of like 3D to 2D representation. Okay, so that's what we need. And then what we will do is we will first of all create the numpy zeros using these data points and the number of columns. Okay, so once it is done, so what we can do is now we can set the numpy. Okay, p is equals to np random dot seed we can set here. So we can set it to 42. Okay, or we can mention some seed, and we will mention this default into your function itself. Okay, here we can write here seed is equals to, let's say, 42. Okay. And then after that, setting the seeds, we can define one something called angles. Okay, the angle is equals to, we will define here like np, and it's going to be inside a tuple. So we are going to have numpy dot random. Okay, random numpy, and then random random here, and then we have to specify the data points that we want to create, random data points, multiplied by, or take a cube of it, and then plus zero point 0.5, and then we can multiply it with by 2, and then your pi. Okay, numpy dot pi, this is for the an uneven distribution we are going to create here. Okay, and then what we have to do is we can get the, in the x we will get all the rows and the zeroth column, as well as in the x itself we have to go for the other ones, that is the first column. Okay, so here we can just take it equals to, we will just take the cos of the above. Okay, cos of the above angles that we have created, and also we will take the some sine of the above angles plus some zero point 0.5 to just make a difference here. And then after that we will do what, we will add some more noise into your x data. So we will just write is equals to 0.28. Okay, that is one more data maybe. And then we have the and numpy dot random. Okay, and then we will create random normal. Okay, random normal, in like we are adding, actually we are, what we are doing is we are actually adding more, some more noise. Okay, so this is adding some more noise here. What we are doing is we are creating some sort of, you can say, oval shape here, and here what we are doing is we are creating some uneven distribution. Now for this, what we will do is we will return the x data, and we will add some more. Okay, like some sort of shifting. Okay, 0.20, maybe zero point 0.3. Okay, that's all. So this will create some random data. Okay, so it's a like uneven data it will try to create. Okay, so it's not of an, you don't have to remember anything about it. Okay, it's just a way of creating a generate data. That's all. So we have got the data first of all, and then after that what we will do, we will create a data frame out of it. So data frame is equals to, we'll create an empty data frame. Okay, data frame which will take this x train, okay, as an input, okay, as a data. And then we can specify some columns as well, like we can specify the column names here. So columns is equals to, we can say that x. Okay, then we have y, and then we have z as well. Okay, so this is the 3x data that we have. And then what we have to do is we can print the description of it. Okay, so like we can say that, okay, description of, or uh, statistical description, or maybe, okay, description of data frame df, and it is given as, I will give it as a new line. Okay, in the new line we will give it, and here we can mention the df dot describe, and we can also make a transpose of it. Okay, because sometimes it looks like, doesn't looks very clean here, so we can make a transpose of it. And that's all, I think. Okay, so this will, first of all, let's try and run this till this part, that whether it is working fine or not. So we will write as Python source and then main.py. Okay, because it's present in the source folder. Okay, so let's run it. So it will generate quickly and then it will simply give you all these details. Okay, so it has generated this. Okay, now let's visualize this as well. So for that we will make use of plotly. Okay, so we will create a figure is equals to, we will call for this px. Okay, what is px here? This is nothing but it's a, as you can see, express.px. Okay, plotly is so px dot, we will call for the scatter 3D method. Okay, and here we can specify the data frame that I want to present, and then we can specify the what x will be containing. So it will be containing your x data points, that is the column name that we are specifying. Then y, what y will be containing, so we will write y. And then we have the z as well. So z is equals to z, what is z will be containing, so we can specify it here. And we can also mention some sort of opacity we can give here. Okay, opacity, let's keep it to 0.7. Okay, and then after that we will call for figure dot show. That's all. Okay, so this will show the initial data points of it. Okay, and it will show it in your default browser. Okay, so right now it is open here, so let's try run this again. So if we just click on here, so it should pop up here. Okay, if everything is fine, yes, it did. So you can see this is the data as you can see on the screen. So we have this data here, this is x, y, and this perpendicular axis is the z axis. So you can see the data is scattered in this form. Okay, so there is a scattering in this way. If you just look from this side, so you will see there's again scattering. But if you just look into the variations, so variations will be varying in this xy plane only. Okay, so let's see. Okay, if we is able to reduce the dimension or not using the autoencoders. So what we will do is we will go back again and we will now write the next thing. So what we will do is we will write the encodings that we can get. Okay, so encodings is equals to, we will get it from the model that we are going to create. Okay, so for that we have to pass the data first of all, extrain data. Okay, and this will pick by this model. Okay, now what we can do is we will write the models first of all. So before this, what we can do is, let's do one thing, let's commit this till this part. Okay, so we will make the changes. I will say that we have created the data gen complete. Okay, there's some modification mods. Okay, so now after this we can now continue with the creating the model. Okay, so first of all what we can do, we can set the seed df dot random dot seed, and seed is not defined here, so we will define it here. Seed is equals to, let's say, 42. Okay, and then after that what we will do is we will create an encoder for us. So it's a very simple encoder. So we will write here tf dot keras dot sequential. Okay, and in this one we will just have only one layer. So this will actually contain the tf dot keras dot layers dot dense layer, and this dense layer will contain only 2 units. Okay, and then just like this we will create a decoder as well. If you can remember, this is the same diagram that we are trying to do, like we have seen in the previous lecture. Okay, so we'll be having this decoder, and this decoder will be having a unit of 3 because 3 is an output reconstruction outcome. Then at the end what we will do is we will create an autoencoder. Okay, autoencoder. Okay, so autoencoder, what it will do, autoencoder will be is equals to, again going to be, again this is tf dot keras dot sequential, and it will combine these encoder first and then decoder. Okay, so this will create an autoencoder. Now after this we will define the optimizer. Okay, optimizer. So optimizer, what we are doing is we are creating, let's say, a sgd optimizer, so sequential, not this, tf.keras, and then we have the optimizers, and then this is an sgd optimizer whose learning rate is LR, and this LR is now defined here in the argument. Okay, function argument is equals to, let's say it's going to be 0.5. Okay, so we have got the optimizers now. Now we have to write what, autoencoder, and we can compile it. Okay, so compile. So compilation of the model will take loss is equals to this is MSE loss we are going to use, very basic. Okay, it's because it's very basic like autoencoder. Then optimizer we can specify is equals to optimizer, and then we have the like we can have history here to plot us. Okay, plots the detail. History is equals to autoencoder dot fit. Okay, and here we can just train this. So you can do one thing, you can understand here. So we have the input as well as output, both of them are the same. Okay, that is x train only because we are trying to reconstruct it. So target column is also going to have an x train only, and then epochs is equals to that how many epochs we want to run. So epochs is equals to, let's say we want to run it for epochs. Okay, and this is also again a keyword which can be mentioned into your function. So it will be is equals to, let's say we are going to go for maybe 500 number of epochs. Okay, so that is done. And next thing that we are need is, we need the that whether you want to print all these details, so that is up to you. Okay, that is history. And then after that, we can, once it is trained, so we can return the model here. Okay, so encoder dot predict outcome we can share, and this we can just pass the x train here information. So this will create the model, or actually you can call it as a get prediction. Okay, okay, get prediction. So we can call it as this. So this we will get the encodings here. Encodings. So this will give us the encodings. Okay, so let's see if we. Okay, I think that is fine here. So we have got the encodings right now. So after this, what we will do is we will get the prediction. Okay, prediction data frame. So that prediction data frame will be equals to pd dot data frame, and it will take the this, it will concatenate this. What I will do is, like, see, this encodings will be having a two-dimensional, right? So if I want to show this into 3D plane only, so that I can show you in just single plane, so for that what I have to do is I have to actually I will create a numpy array where I will concatenate zeros for all the z-axis. Okay, so C and underscore concatenation I will do here, and I will pass the encodings that I have just got. Okay, and also I will pass the numpy zeros. Okay, numpy zeros, which will be having a shape of these encodings. Okay, dot shape 0. That means whatever is the length of it, these encodings. Okay, so that will create like concatenated, actually, and it will create a like matrix like this. Let's say if you have a data of like 1 comma 2 comma something, so it will have 0, and then 2 comma maybe 2 comma and then 0. So the 0 0 is getting, now the 0 0 at the end is actually getting concatenated here. Okay, so in this way we will get this, and then we can create a columns here. Column name we can specify. So column names we can say, let's say first one is going to be having a new x. Okay, and then we have the new y. Okay, new y, and then we have the none. Okay, we are not defining any z, so we will give it as a none. Okay, just a giving name. So this will be your prediction data frame, right? And then what I will do is I will also print these the new data frames description. Okay, so we will just copy paste from here. I will print it again, and I will mention it here as this is as prediction data frame and its description. Okay, so this will print the description of this prediction data frame. And once it is done, so let's do one thing. So after this, what we will do is we will again create a figure here for this. Okay, scatter 3D. And now what I will do is, instead of this, I will pass this prediction data frame, and instead of x we have the new underscore x, that is the column name. Y we will be having a new underscore y, and the we will be having as a none by name. Okay, so this is what we are going to produce, and this is the result that we are going to get. So let's try and run, and let's wait for the moment, and this is going to be interesting. Let's see this. So hopefully there should be no error, and let's see, okay, what are the outcome you will get. And let's, yeah, so see here, so this is your input information. Okay, that means it's in 3 representation. You can see there is its data is carried into all 3 directions, right? X, Y, and Z. Let's wait for the training and the results for the next. So it will pop up here only. Let's see. Okay, there was an issue here, so has no seed. Okay, this is, I think, at the X train, and this, okay, random dot seed. Okay, we have, okay, so this is in TensorFlow. We have the random dot set seed. Okay, it should be set underscore seed. Okay, there should be, that's why I was thinking that, okay, why you are not getting an error. Okay, but if you are not getting any output here, so let's see, let's hope we get the outcome now. Okay, the first outcome will be, again, it will be a data only. So this is the data that we have got. No issue. Okay, there is one more. So we have optimizer is equals to, has no attribute optimizer. Okay, there is some issue again. Optimizer, optimizer. So we have, I think we have mentioned it into this error is actually into your optimizer. Okay, it's optimizers. Okay, here this is optimizers. Okay, so see, these are some minor mistakes that you may come across, so that's very normal. So let's see again the outcome. Got the data again. Let's hope that we get the prediction as well. Yes, it's trying to predict. So right now again the data is scattered into 3D. Now let's see here. Moment of truth. We can see that we have compressed the data into a single plane. That is, you can see the data is now aligned into just one plane. And what is that plane? The plane is XY. So okay, so that means you It's kind of, this is called as dimensionality reduction. So what we have done is we have reduced the dimension to just a two dimension. Okay, right now that is why I have made it for the 3D, because so that you guys can understand that okay, how this data was scattered. So you can just see. Let me keep it side by side here so that you will get the clarity here. So you can see this is the same data. If I look at from the x-axis through x-axis, you can see here it is scattered called vertical, and now it is compressed to just one single plane. So that is called, that means we have reduced the dimensions. Okay, if you want to visualize this if you want to visualize this not like this, if you want to visualize it 2D dimension, two dimensional, so you can do that as well. Okay, so that is also possible. So that was just a basic demo of like how you can convert, like how the 3D representation can be done into 2D as well. Okay, so that's what it is. Okay, if you just look into from the top, and if you just look at this also from top, it will appear, okay, it's almost similar, right? See here, and if you just from the sidewise, if you see, so there is no z direction. Okay, that means there is no z expansion, it's just on one plane, xy plane. Okay, so that's all for this lecture. I hope you have enjoyed, and if you hope you have got the basic clarity of that, okay, what autoencoder can do, and we will have more fun experiments in the next lectures. Okay, so that you will have more and more clarity of it. Okay, that's all for this lecture. Thank you.